Right, here with I'll show my structured model paper number 6 solutions. Already I published that paper, 6th pure mathematics structure type 10 problems there. So I hope you complete this before me and you can check with me my answers, solutions. There are so many methods for a question, some problems, so many methods, but final answer is same. You decide which is too short method within short period to get the full 25 marks. Okay, first question, the pure maths as usual, mathematical induction pattern, induction form. Show that sigma notation r over 2 to the power r equal 1 to n is that answer summation 2 minus n plus 2 over 2 to the power n. So you know in my this I think third pure maths paper, therefore you know how to work this the fourth pure maths paper. 2 applied I completed. So every four papers I publish this induction. It's the way in the pure maths paper. First question, induction. Okay, for first step, if n equal 1, show which is true when n is 1. So LHS left hand side. Sigma r equal 1 to n r over 2r, n for 1, so 1 to 1, that means first term, only one summation, that means 1, first term. So what did I put r for 1 over 2 to the power 1, that is half, left hand side is half, LHS is half, and see right hand side, RHS. What is that value? Right hand side, put n for 1, so 2 minus n for 1 plus 2 over 2 to the power 1, and show that also the same answer. Is it what is that? 2 minus 3 over 2, that is half. Therefore, LHS equal to RHS. Both sides same. That means what? The given statement is true for n equal 1. You write a word below. Therefore, the given statement is true for n equal 1. Next, the assumption, right? Next point, assume that true for given statement, right? True for n equal p. Assumption, assume that the given statement true for n equal p. So then let's try, that is try copywriting, put n for p and write sigma r over 2 to the power r equal 1 to p. That's equal, other side 2 minus p plus 2 to the power 2 to the power p. That's all. Let us try copywriting n for p. Next, last part, important. If n equal p plus 1, if n equal p plus 1, show the given statement is true for n equal p plus 1. Then it is true for every integer, positive integer of n. So what that? Therefore, sigma r over 2 to the power r for what? 1 to p plus 1, n for p plus 1, adding up to p plus 1 terms. How that? Add up to p terms and the p plus 1 term. So it can be shown as sigma r over 2 to the power r 1 to p, first p term summation, plus the p plus 1th term, u for the term, p plus 1th term, right? So wherever we use the n for p plus 1, we need the assumption n for p. Copy the n for p answer here. That means sigma r 1 to p is this answer. We substitute here. 2 minus p plus 2 over 2 to the power p. Okay. Plus p plus first term, p plus 1th term. How that? If you put r for 1 first term, if you put r for 2 second term, here if you put r for 10 10th term. So p plus 1th term is write r for p plus 1. So what is that? P plus 1 over 2 to the power p plus 1. So what is the answer to be? If you simplify this, the answer becomes what? You can check before completing the answer, before the idea. What the answer to be if you simplify? 2 minus n for p plus 1 plus 2. That is p plus 3 over 2 to the power p plus 1. This is the method. The answer you will show if you simplify this. So do the rest. If I show here, that's equal 2 minus p plus 2 over 2 to the power p plus p plus 1. Can I expand this? What is indices? 2 to the power indices part 2 to the power p plus 1 is 2 to the power p into 2, is it? Because the bases are same when indices multiple at the power. So therefore 2 minus, can I take 1 over 2 to the power p out? Common factor, take that one. So here p plus 2. Okay, your positive I use minus out, therefore minus p plus 1 over 2, is it? Okay, so simplify that. Then what happened? That is 2 minus 1 over 2 to the power p. Using this LCM to simplify, we multiply here 2p minus pp. 2 minus 1, that is 1. 4 minus 1, that is 3, plus 3. Plus 3. Therefore, the answer 2 minus, show this actual problem, p plus 1 plus 1 plus 2 over here bases same, p plus 1 when you multiple. Therefore, see in the given problem, substitute n for p plus 1. N for p plus 1 is available. Therefore, this is true for every integer n. It's the way of simplifying mathematical induction. Very easy question. It's all the past many from 2019 onwards behind that every paper. First question is this. Very easy. Everybody can get the first 25 marks quickly in short period. Time also important. Okay, next second question. This is the inequality modulus graph is given here. So the question says the graph is provided x-axis, y-axis. They shown the graph for what? Y equal mod x minus a. So I hope you can draw that. Without that, they provide the answer. The graph is drawn here. Otherwise also you can draw using the modulus definition. Mod x greater or equal 0, how? Mod x less than 0, how? That is the shown, right? The graph goes like this. The graph is shown. This is the we marked the coordinates, right? 0, comma minus a. It's the graph drawn here. Y equal modulus x minus a. So using this graph, they ask, by using the given sketch, graph the given that function. They given a new graph f of x equal minus modulus 3 minus mod x. Okay, minus time 3 minus mod x, draw this graph. Using this idea, they shown the pattern, the shape of the graph. Then you decide how this shape, that's all, no any for the other part only solving. Here using this, roughly draw this graph. So modulus graphs are important using the inside function. Inside positive answer or negative answer, we can give the two part of the pattern. Okay, so can I take first inside the part, if 3 greater or equal mod x, is it? The 3 greater or equal mod x, what happened? It's positive, therefore y equal minus the same as it is, same. So 3 is bigger than modulus x mean this is completely a positive answer, positive, mod is positive. So therefore no change in the modulus sign, the minus available and inside. So what is if you rearrange y equal mod x minus 3 mod x minus, that's you drawn. So you can draw this. See a for 3 here, a for 3. So what happened other side of the function, if what that 3 less than mod x, for every modulus 2 parts there, for a positive side and a negative side, right? I hope you complete the theory class everything. So what happened, therefore fx equal here a minus, so 3 is smaller than the modulus, therefore inside negative, inside the modulus minus symbol, then we have to put an extra minus, that is minus into, write what is inside. Okay, that means what, f of x equal 3 minus mod x. Okay, one is this. So here I am showing briefly. If you can clearly, you can verify from there what the shape. See, these are the parts. One is this, other one is this. So you can think in this case is okay. So here what happened, minus. So here become that's other side, converse in minus part, right? Yeah, the graph is rough sketch. Here you need the positive 3 here, 1, I mark 1, 2, 3. Here also same, minus 1, minus 2, minus 3. And first you can draw this one straightly by using the given question. Here downwards 1, 2, 3. Okay, so if I draw the first one, it goes like this, 2, 3, you know. Not parabola, straight line. The intersection points are in the first graph. That's the first graph as I mentioned from there. This part is okay, 2 parts. And how the other graph, you can see how the other graph, 3 minus modulus x, so also has 2 parts. Every mod graph usually 2 parts. So if x is greater or equal 0, x is greater or equal 0, that is same y equal 3 minus x. If x is negative 0, it becomes 3 plus x. 2 graphs can draw. This part comes, if I draw different color, if I show different color, it becomes like this. See, if you can produce it, you can produce there 3 minus mod x. So if your x is positive, x is the positive side, 3 minus x shape. If x is negative, 3 plus x, that becomes something like this. See, very important here, this 2 becomes parallel. I am showing the extra work. This 2 parallel. Okay, these 2 graphs parallel. Also, this 2 becomes parallel. Okay, because of the gradients are equal. Gradients are equal. But here, if you take the completely mod graph, completely modulus, therefore, in this case, we won't take this part and we won't take this part. Okay, it's the final answer. Completely modulus graph. See, completely modulus. So, is this using the previous? Quickly, you have to sketch that. If any problem, you follow all the modulus instructions and step by step compute your table form, any other method. Try the graph come like this. Okay, now they ask, which is by using the graph which is obtained from the given graph, find the set of the values, positive values, satisfy the equation. So usually our paper, you can see they will ask a modulus inequality using the graphical representation or any other method also. Now only they ask a solution, solve that inequality. Solve the inequality what? 3 minus mod x greater or equal x. Okay, 3 minus mod, here we have already drawn here 3 minus mod x part, this and this, right? This and this, 3 minus mod x part there, greater or equal x value. Therefore, better I draw a new diagram, and so it's okay. There are actually 2 parts of the question. One is draw roughly this sketch using the given diagram. Now different solve. Better you draw new diagram and work there. So I hope you completely check with your answers. So if I draw this 3 minus mod, there is 2 parts, right? We need the intersection points are important here, 1, 2, 3. Also here -1, -2, -3 and so on. If you produce it, you need up to 3 there, positive 3. 1, 2, 3 and so on. Here the y-axis, x-axis. How this graph? You already drawn here, 2 parts there, it's 2 drawn, right? So here 3 and here 3 and -3. This simple question or difficult? Not difficult, the graph is sketched already. Sometimes that is a problem for you. Otherwise, ordinary problem, right? Okay, this is the part we drawn, one for this part. Y equal 3 minus mod x graph. It has 2 portion. If the x is positive, 3 minus x. That's this side. Y equal 3 minus x. Okay, if x is negative this side, x the negative direction, less than 0, y equal what? 3, put extra minus plus x. Okay, this is the graph. Now this is a new part, x. If I take this is y1, greater if I say y2, explaining method, there is no y1, y2, x and y only. If I assume that I am explaining like that, draw this graph also. What is yx? Y equal x. Y equal x, primary work. Through the origin graph, straight line. X0, y0, x1, y1, x minus y, through the origin. Okay, like this. Y equal x. Y equal x, draw the graph past the origin. Actually, this to become parallel, right? That's also important question. Ideas for problems, lines are parallel. This I say y2. This is y1. Here also the black color I drawn y1 graph. and this is y2, right? After drawing, you see the intersection coordinate where the both cuts. Intersection coordinates are important. Find this coordinate. That means solve these two graphs. These two graphs solve y equal x, y equal x, and y equal 3 minus x. Solve these two equations. Solve and find the x coordinate where the both cuts. So if you equate it, 3 minus x equal to x. So 3 equal to 2x, x equal 1.5. Is it? Or 3 over 2, is it? X equal 1. Check that, 1.5 or 3 over 2. Yeah, for this part 3 over 2. Then go to the answer. The question is, this is greater or equal that. Positive solution they ask. Therefore, according to my graph, the black colored diagram upper than this part up. Y1 is larger, Y2 small. That means particular x values, see particular x values. Here Y1 up, here Y2 down, Y1 up, Y1 up, Y2 down. So we can take this also. You can take this also. This side, negative direction. But they ask the positive value of the x. So if you come here, what happened? So see this part. Here see particular x value, y1, here y2 up, y2 is up, y2 is up, y1 down, y2 up, y1 down. You can't take this part. You can't take this part. See this portion between 0 and 3 over 2. From 0 to 3 over 2, right? Between 0 over 3 over 2. This y1 graph up, y2 graph down, right? This is up, this is down. That means particular y value. See particular x value, y coordinates. This y becomes larger than this for what range of the x? Between 0 and 3 over. There's the positive answer. Therefore, x solution 0, 3 over is method like this. They show the equal symbol also. Then you can do a box bracket called the equality. Or you can write this form 0 less than or equal x less than or equal 3 over 2. Negative side also we can take minus infinity up to minus infinity. But they ask the question is positive range of x. Therefore, this is the answer. Okay, question number 3. It's a binomial part. It will be some trigonometric issues. How that question in the expansion x over sin theta plus 1 over x cos theta completely power 20. So using the binomial method, you can show some expansion 20c1 naught plus 20c1 like that pattern. There are 21 terms available. They say L1 is the coefficient of the x square. L2 is the coefficient of the x to the power minus 2. Then find the answer L1 over L2. So before that we have to find which term belongs to x square. The square comes in the expansion, square comes which term? Third term or seventh term or fifth term, which term we have to find. Same method, find which term takes x to the power minus 2. For the idea, we have to write the general term of this expansion. So write below general term TR plus 1. Here we denote as T form, TR plus 1. TR general term coefficient usually you call u term, small u like that. So what the general term therefore 20 CR x over sin theta to the power 20 minus r into the other term 1 over x cos theta to the power r, right? This is known as the r plus 1's term. That means general term of this expression. Now simplify this. Single you take how many x to the power there? X to the power. So if I simplify 20 CR x to the power, here see 20 minus r, below x to the power r. If you take total, what happened? 20 minus, is it 2r, is it? Here x to the power minus r, it's take up 20 minus 2r, that's the x to the power. How the other trigonometric expressions, 1 over sin theta to the power 20 minus r, also 1 over cos theta, okay, that's equal to the power r. Is it okay? Right. It's the general term of this expression, right? Therefore, I need x to the power 2x square, which is completely becomes square. I want to find r is what? Which term belongs to power of the x becomes 2. X square is 2. So this becomes 2, right? Find the r value. Later, this becomes minus 2. Find the r value. Therefore, you can write to find the coefficient of x square, write that. To find the coefficient of x square, to find the coefficient of the x square, 20 minus 2r to be equal to 2. To be equal to 2. So solve this, what happened? 2r equal to 18, r is 9, right? That means which term? r 9 mean not the 9th term. You see? 9 plus 1, 10th term. It's not only for this question. Every problem hereafter over the past papers, you need this idea, right? So r9 mean not the 9th term. Come here. 9 plus 1, 10th term. Therefore, if we expand this binomial part, there are 21 terms available. 10th term, how? Its x power is 2, right? Its x power is 2. Therefore, you know the coefficient, there's that L1 is the coefficient. Therefore, we can write that, or we come to the other part and come to the answer. Find the minus 2 also. So next you can write, to find the power minus 2 of x. To find the power of x minus 2, to find the power of x minus 2, 20 minus 2r to be equal to minus 2. Therefore, find the r value here, 2r equal to 22, so r equal 11, right? R equal 11. Okay, therefore here what second occasion, x to the power minus 2 comes what? Which term? 12th term. R is 11 means 12th term, right? Therefore you know those coefficients. So if there's the L1 over L2 ratio, see therefore L1 over L2, when they ask this, theta is pi by 4. That is, you can substitute this, 45 degrees, theta equal pi by 4. Okay, what is L1? What is L1? X square coefficient. X square is 9th term, put 10th term, R4, 9, R4, 9. So first to complete L1 is what? Put R4, 9, put R4, 9. 20 C9. These are the this is not coefficient. These three parts are the coefficient, right? So 1 over sine theta, or you can say pi by 4. sine pi by 4, 20 minus 9, 11 into 1 over cos pi by 4 for R9. This is L1, okay, that is L1. Same method, write the L2. What is L2? R to the power minus 2 coefficient, right? It becomes R4 11. Is it R4 11? Okay, R4 11, write that. Here 20 C11 1 over sine pi by 4, because they ask when theta is pi by 4, right? To the power, what is that here? 20 minus 11, 9, and 1 over cos pi by 4, and what is that here? R4 11. Nice question, nice work, but simple problem involving trigonometric binomial idea. So if you learn in the theory class that binomial, there's a theory, one of the theory, NCR equal to NCN minus R. That proof also there in the past papers. NCR equal to NCN minus R, right? Example, NC5, if I say 20C5, 20C5 equal to what? 20C15. Check this. If I say 10C2 equal to what? 10C8. Okay. So according that 20C9, 20C11s are simplified, cancel. That is cancel, right? And here see sine 11 times up, here 9 times. Therefore 1 over sine pi by 4 square up over here cos 9 times, here 11 times. So 1 over cos pi by 4 2 times. See, actually these both are same. You know, sine, cos, both pi by 4, same answer. Therefore not a big issue. Answer is 1. Sine pi by 4 1 over root 2, cos pi by 4 1 over root 2. Therefore answer is 1. Right? Nice question. Keep in touch as I work this my I think 5th or 4th binomial problem with my model structured papers. Every paper I shown one question. Okay, see next question number 4. Problem number 4, limit question. Limit infinity. Is it? Yeah. Alpha tends to infinity. Is it 0? Alpha tends to 0. Tan alpha over third root of 1 minus cos alpha, all things square. Okay, so another series of videos I am showing the limits, revision limits also. Many questions I work and the 2 videos I want to implement. A good question there also, some revision type model limits. So here, so what the idea of a limit, if you apply that alpha to 0, what happen? Alpha to 0, tan naught naught, here cos naught is 1, 1 minus 1 0, 0 over 0, one of the meaningless form, right? Therefore you have to use any, it's good question, you know, patta ganam maker, yeah, my good idea to solve, right? So I hope you work this. So some says answer me that patta ganam arui, some say difficult, some short of out of syllabus something. Okay, we'll see the idea. The answer never comes 0 over 0. Answer never comes what you call infinity over infinity. There are 7 meaningless pattern. If you have problem in limits, watch my 4 videos I publish, especially in limits revision, right? Okay. So in this case, I try to work, I write the tan alpha sine over cos. Okay, limit alpha tends to 0. I write the tan is sine over cos. Okay, and the third root of 1 minus cos alpha all things square. Third root, right? Thereafter limit alpha approach to 0, alpha tends to 0. Now I take this cos, no problem, because cos naught is 1, right? Cos naught is 1, cos no matter in the limit part. Sine over sine we have theory. Tan theta we have theory, cos no theory. So because cos naught is 1, that is safe. Therefore now I change, I take the sine alpha also inside the third root. Sine alpha also I take inside the third. What happened? 2 take in the third root becomes 8. 10 take in the third root becomes 1000. 5 taking 125. 6 taking 216. So like that, here cos alpha, there is no doubt you keep as it is, cos alpha as it is, and let's say 1 over cos alpha. Completely third root, the third root, sine take inside. So what happened, that is sine cube alpha, okay, sine cube alpha into 1 minus cos alpha all things square. Okay, sine cube alpha over 1 minus cos alpha all things square, right? The next part, 1 over cos alpha, 1 over cos alpha, third root, sine cube alpha. What is sine cube alpha? Sine alpha into sine square alpha. Sine alpha into sine square alpha, right? Therefore, sine alpha, that's sine square alpha. What is that sine square alpha? 1 minus cos square alpha. 1 minus cos square alpha over 1 minus cos alpha completely square. Completely square, right? So therefore, limit alpha approach to 0, alpha tends to 0, 1 over cos alpha, you can factorize 1 minus cos alpha, 1 plus cos alpha, okay. 1 minus cos alpha, 1 plus cos alpha. Therefore, sin alpha, 1 plus cos alpha over, another 1 minus cos cut down, right? 1 minus cancel. 1 minus cos, 1 minus cos square, 1 minus cos, 1 plus cos. So 1 minus cos cancel. Here another 1 minus cos alpha remaining. Okay. 1 minus cos alpha balance. So now what happened? You can change the double angle formula. Double angle formula, change the double angle formula, both of these. If I show once again, what is cos 2 theta? Very useful, double angle cos 2 theta. 2 cos square theta minus 1 or 1 minus 2 sine square theta. Therefore, change that manner. Limit alpha approach to 0, alpha tends to 0, 1 over cos alpha, third root. So I want to change everything to double angle part, right? So what is sin alpha is 2 sin alpha by 2 cos alpha by 2. Okay. 2 sin alpha by 2 cos alpha by 2. So nice question, nice work. So it can be expected in the future papers or something like this, or if your idea is important, that's why I'm showing such a model questions. What is 1 plus cos alpha? 1 plus cos alpha is what to rearrange. 1 plus cos alpha. 2 cos square alpha by 2 is it? 2 cos square alpha by 2 over what is 1 minus cos alpha? 2 sine square alpha by 2 is it? 2 sine square alpha by 2, okay? 2 sine square alpha by 2. Now simplify, see here a 2 cancel, okay? And 1 sine alpha, here a sine alpha cancel. Okay, 1 sine alpha, here a sine alpha cancel. So remaining 1 sine alpha by 2 available. So simplify and see sine square alpha by 2. So inside the root, third root, cubic, third root, below cos alpha, what is inside? Cos into cos square, cos into cos square, cos cube. The third root cos cube is take out cos alpha by 2, okay? So what the inside part, third root, there's a 2 and below sine alpha by 2, sine alpha by 2, okay? So if you straightly substitute alpha to 0, which is comes that 0 over 0, one of the meaningless pattern, indeterminate form, right? Therefore step by step we go to find, you're the same, put cos alpha for 0, see 0 over 0, you can't determine the answer. Find what happened here. Now apply alpha for 0, cos naught 1, alpha to 0, cos naught is 1, and inside the root what happened? 2 over sine naught, there's a number, numerator there's a value, but denominator 0, a number divided by 0, infinity. It's the Pattagana Muttara, infinity. It can be anything. It can be any answer. It can be infinity. Answer can be infinity. Answer can be 0. It won't take one of the 7 meaningless pattern. 0 over 0 cannot. Infinity over infinity cannot. But 0 uttara kenta puluvan. Ananta dakwa yanta puluvan answer. But straightly won't come 0 over 0. Infinity over infinity.